Hey guys, today we're doing cook-off. It's been a while since I've done one of these like explicitly, and well, I'm doing it officially. So you might want to expect lighter commentary, since I'm probably going to be fighting to keep 7-star, and speed is going to be important for that. So I'll do what I can, but at the same time, it's rated, so who knows. Let's see. I'll update the sub count as always. Still trying to get to MLE. Let's see. And yeah, that's about it. We'll see if the site loads this time. Everything else is set. Alright, so we have 6 problems. Cool. I have not read anything about this contest. Wait, what did I miss? Alright, we'll see if these are ordered. You have N students participating in the Indian programming camp. Oh, nice, about this. And I watched a total of K lectures. Each student I, and each lecture J. I student wants a Jth lecture. This is div 1, right? Just to be sure. Yes. What is the criteria for getting a certificate? The criteria for getting a certificate. Wait, is that just it? Like we just do this? They must have watched at least M minutes of lecture in total, and they must have asked the question no longer than 10 times. Is that it? So we just straight up verify. Okay. How does this work? So it's N, M, K. Then we don't have multi-tests. K, J++, Cn to Y. If S is greater than or equal to M and Y is less than or equal to 10, it's no more than 10 times, right? Yeah. So we just like straight up implement the problem. Just do what it tells you to. So are these the types of problems they're giving now, or have I misread this somehow? 3513. So check the sum. This should be greater than that. Okay. So it has to be at least M and at most no more than 10. That means it could be 10. So yeah, okay. And of course, we're not doing anything stupid like overflowing. You're given 2 binary strings A and B with the same length. You may pick a substring A with odd length and invert all of the bits. Change the string A to the string B. Okay, so the idea here, I suppose, would be that consider like the strings. You want to make them equal. So what you can do is you can make a new string where a bit is 0 if they're the same, and 1 if they're different at this position. So kind of you create a string from the XOR of the 2 strings. And then now you want to make this string equal to 0 so that they're all the same. And the way to do this is to let's see, how would you do this actually? Essentially in one move, it's the how'd this work? In one move, you can like remove the groups on the ends, but at the same time, you can like so if you break them into groups of 0s and 1s, and like in one move, you can remove say you do some move that affects some groups, right? So like, if you have k groups between them, then now you're going to have k plus 1. Or like you have 3 groups here, but then when you flip all these zeros are going to become 1s. And in general, you can only reduce the number of groups by most 1 each move. So I think the answer is just the number of groups. Yeah, that sounds right. Let's see. So c into s to t, n equals s dot length, string v, v, actually wait, ai equals si is equal to ti. And this should be test cases. Now, if ai is equal to 1, and either it's the first character, or the previous one is not equal to 1, which means this means we're at a new group, then increment the answer and print that. Two zero two. Wait, what? Oh, it has to be odd length. Oh, that's weird. I didn't notice that. Okay. Well, we still have this. Why would that be a thing? Does that make anything harder? I'm not actually sure. Wait, pick a substring of A with odd length. Wait, why does sample 3 take 2 of them then? And invert all the bits at oppositions. Oh, that's weird. Okay, well then. That's fine, actually. I guess that just means we can only. Like, we kind of split the string into 2 groups and solve those groups independently? Yeah, okay, that's kind of weird. Alright, that makes sense now. So basically, it's like we can only, like, in one move, we can fix something of, like, odd parity characters, and then same goes for, like, even or something. So then it's kind of like we have 2 separate strings. We have 1001 and 000, and then we're solving for those independently, and we can do the same thing. So this is actually like I is less than 2. So it's kind of just that, I think. We just basically like split the 2 groups into like, we split the strings into 2 separate things and solved them independently. Like, it shouldn't make that much of a difference, right? So this string would be 1011. So then we can do that, and we can do it like that. So I is less than 2 means it's one of the first 2 characters, or the previous character in that group is not 1. That seems good. So 1. Let's see. So it should be. Yeah, looks good. Okay. Just to make sure. Yeah. Alright. Okay. This is a lesson to read the problem. That's a good idea. Manufacturing project consists of exactly k tasks. The board overviewing the project wants to hire k teams of workers. All teams begin working simultaneously. Obviously, there must be at least one person in each team. It takes 8 days to complete the task they're hired for. Each team acts independently and submits their result for approval on the 8th day. Okay, well, we got 2 problems. Right. For a team of 8 workers, it takes 8 days to complete the task they're hired for. Each team acts independently, unaware of the status of other teams. Team of 8 workers, it takes exactly 8 days. Okay. So, essentially, you want the LCM of the values to be x. Right? That's how that works? Yeah, you want the LCM of the values to be x. And you want the smallest number of numbers to achieve that. So first, let's read in, what is it, k and x. And you want 2 teams. Or you want k teams. So everything must be divisible by... LCM must be x. It's some sort of greedy where you assign the divisors of the LCM to things. I'm just not exactly sure how to do it. How would you minimize the sum of each product to make the LCM happen? What's the question? It's the sum of each product. It's weird like that. I know there's some way to do this, I just don't remember how to. Does this exist? Does this exist? Minimize sum of numbers with given LCM. Okay. Hire a team of 3 workers and 1 worker for task 2. Yeah. 3 workers, 2 workers for task 2. Don't understand what we have to do here though. Okay, it's about speed. So let's first prime factorize x, I suppose. And this is where my number theory template comes in, because I don't want to implement this myself. So this is, let's see. All right, now we do the factors. All right, this is gen primes. So we want k numbers with LCM x, and we want to minimize the sum of the k numbers. Is it a sort of greedy, I suppose, where we want to seriously just brute force? Come on. That's not useful. Okay, well, what we can do is we could I guess we have a bunch of numbers and we just kind of ask, like, we put the biggest number down first and then we ask what happens here. And we could do it with bitmaps TP. I'm not sure if greedy is enough. Does it work? Will greedy work is the question. How many people have solved this so far? Is it supposed to be hard? I don't know if greedy will work. Where, like, we start off with a bunch of ones, and then we assign the biggest number to the smallest number that still exists. So for example, say we have like 2, 3, 5, 7, 11, 13, 17, I don't know, 19. And we would put 19 here. And then we put those numbers down. And then the 2 we want to assign, and then the 3 we want to assign to like the smallest number that still exists. I don't know if this works, that's the question. I don't know. How many other people have attempted this? I suppose it would just be let's sort k plus vowels. So also k doesn't have to be too big. Like we can do something like, because it's not that big a deal. You don't need that many numbers. S minus equals IT. Vowels.array, spells.find val, and then s minus equals val, val times equals s times equals val times equals p, s plus equals val, val's that insert val. It should be v. Okay, so first of all, find the factors, do the counts, put them in a map. That's so we can do this power thing. Put them in a vector. Then for each value, like put ones in. Then take the minimum one. Vals.erase, vals.find val. Oh my god, come on. Should get these samples right. Or not. Okay. No, it should be begin, smallest value, yeah. Alright, so basically we take the smallest value, remove it, decrement it from the sum, multiply it by p, multiply it, and add it, and then we continue. Let's see, 105, 125, because we can't separate them, otherwise it would make no sense. 130, so it should be 2, 3, and 5, so it should be 2, 3, and 5. Yeah, and then one more. 1 and 230. Then that should be 11. Yeah. Actually, not sure if this will work. If not, I'll switch it to bitmask DP or something, I guess. What the hell? Given integers n and k, construct a connected, undirected, unweighted graph with n nodes. Does get wrong answer. Okay. Guess I can do something like bitmask DP. Okay, so this is the benchmark. Fix that one, make it better. Alright. This is like small, right? It's like 2 times 3 times 5 times 7 times 11 times 13 times 17. Okay, so 2 to the 7th. 3, 5, 7, 11, 13, 17. Right, and 2 to the 14th times 40 times 100. Does that work? Well, it can even be smaller. It can be like 20, actually. Yeah. Should like dp b max minus 1 plus b minus k. Or something like that. Right, so now dp 0, 0 equals 0. This should be b also. This basically checks if there's no overlap because there's no reason to include a value twice. If nmask and 2 to the j, p times equals val j. Suppose that works. Let's see, it should do better on this one, right? No, it still gets that. So it would be like, oh yeah, it would have to be 5 to the 5th, 5 to the 6th. Okay, so it's not that bad. That's not that good of a case then. So we want something like 2 times 3 times 5 times 7 times 11 times 13. Yeah, so that's 3030. Then this would be like 2, 3, 5, 7, 11, 13. It'd be something like, I'm not sure actually. $463. That's a possible answer. $347. What's that? That's 13. Times What's that? 7 times 5 times 3. So it's not that. It's like 7 maybe, and then 11. I guess that's optimal. And if I try the other strategy, what it will do is... What was the other strategy? That's not what I meant to open. The other strategy was doing something dumb. Yeah, so it gets a worse answer. Okay. If I do something like 3030, it should be something like pairing 13 with 2, 11 with 3, and 7 with 5. So 26, 33, 35. Okay, well, I also believe there's something to be found here. 1. What the hell is that? Okay, wait, what? K minus V. Yeah, okay. Looks better. I'm not entirely sure though. So now we're back to this weird problem. You have integers n and k, construct a connected, undirected, unweighted graph with n nodes such that there are exactly k unordered pairs of nodes. Okay, well that worked. I'm not sure if that was intended, but that's what I was able to do, so I suppose that's all we got for now. Alright, with n nodes such that there are exactly k unordered pairs of nodes, probably should have just done this in the first place, avoided the penalty, just to have been sure about it, but whatever. Nothing I can do now, I suppose. Construct a connected, undirected, unweighted graph with n nodes such that there are exactly k unordered pairs of nodes which have distance equal to the diameter of the graph, or determine that no such graph exists. N nodes. Why unordered? 1, 5, oh, unordered, okay, sure. So we fix a certain length of diameter. That is, we say the diameter is going to be 2 or something. And like kind of, like we fix a certain length of diameter, and therefore, we have some sort of path like this. And then we're going to kind of stick things onto it. Which values of k can we even attain? Interesting. So we can kind of like add edges to make everything else kind of behave however we want, I suppose. Somehow we get k. Maybe we have to prime factorize k and see what kind of things we can do with that? Or is it easier than that? We have to print the graph itself too. It's like, when is it not possible? When k is too big, it's not possible. Precisely which values of k can we get? Like, if the diameter is length 2, then we're forced to have a star graph. Just because that's how it works. So if the diameter is length 2, or length 3, however you want to say it, 2 edges, then, well, we can't attach any sort of node to these two, otherwise the path would be longer, so we have to attach all the nodes to this, and therefore the graph must be a star. Let's say we have 3. Then we have to attach nodes to these, and with 3, it's kind of like we have, it's the multiple of these two. Yeah, it's the multiple of these, sort of. Because we'll have 3 on this side and 3 on this side, and all of them are equal distance from each other. If we have a diameter of length 4, what does that do for us? Well, it means we can start adding new chains, kind of. So, like, for example, like so, where if we add something like this, then we could do this. And then now we have this matches with this and this, but we can also add some special edges to make it so the paths are shorter. So for example, we could do this edge, and then like we wouldn't, we would only have 2, which is kind of interesting. So what I'm kind of thinking is, what if we like had a star graph, but we added some edges to make it so it would like not be valid or something? So every path is length 2 for now. And therefore we have n times, no, it's n minus 1 times m minus 2 over 2 nodes, or over 2 pairs. And then from here we can add this edge. And so it invalidates only this pair because everything else is still of length 2. And so we can also add this edge, kind of. And we can add whatever edges we want, and it kind of like, I think that kind of just works. Like, every edge will invalidate exactly one pair, which means we can get any k that's less than or equal to this. And so the only special case is n equals 2, in which case, then we're kind of screwed anyway. Well, if n equals 2, actually, then that kind of just works. So if n equals 2, then the special case is that. So we have 2 times 2 minus 1 over 2. If n equals 2, CL 1, 1, 2. Otherwise, let's see. C to n to k. First I'll read the input. Don't be an idiot. Now, for LLI, no, ln max equals n minus 2 minus 1 over 2. And the reason this is always going to work is because, like, okay, the diameter must be at least length 2. Because if we have more than 2 nodes, the diameter must be at least length 2. Connected, yeah, connected. So the diameter must be at least length 2, otherwise it wouldn't make sense. And therefore, like here's the reason. So we put this down here and we put this down here. Okay, so now we have to now we have this other node. What do we connect it to? We have to connect it to one of these, and then the diameter is length 2. So then we just continue. But if the diameter is length 2, the best we can ever do is a star graph. Because like the thing in the middle can't ever be part of the shortest path, because there are 2 things on either side of it. So therefore we lose the n minus 1 things from this, and therefore we're left with this. So if k is greater than max, see out -1 turn, and otherwise, so for li equals 1, I is less than n, I plus plus, push back, make pair 1, I plus 1. Now, while let's see, 1, I is less than n, I plus plus, for LOJ equals I plus 1, j is less than n, j plus plus. If max is greater than k, then add this edge, which will decrease the edges by exactly 1, j plus 1, minus minus max, see out edges dot size, that looks pretty good. So we have 11, let's see. So we have 6 nodes. Consider it like this. We have 1, 2, 3, 4, that. And we have an edge between 2 and 3. So let's do it like this. 2 and 3, 2 and 4, 2 and 5, 2 and 6. We have an edge between 3 and 4 and 3 and 5. Which means the number of things that are the number of pairs that are 2 nodes apart are this one and this one, this one, and this one. So that's 3. Then this one and this one. That's another one. And that's it, I think. This one isn't with anything else. It's not with either of these. And this one isn't with this one. So it looks good. Let's see. There's no local variable stuff. So let's do 3, 6, 6, 0, 6, 1, 6, 36. What's the maximum? So it would be 5 times 4 over 2, 10. So this would be print all the edges. Yeah, and then one more. 1, 6, 11. Seems good. Let's just sanity check ourselves. So read in nk. If n is 2, let's check that. 1, 2. That wouldn't be a valid input, having 2 and 2, because it has to be 2 times 2 minus 1 over 2, which is 1 at most. So the only valid input will be 2, 1, and therefore the only edge we have is that. Yeah, so if n is 2, print that. If k is greater than max, print -1. Otherwise, make the edges, make the star graph. For each thing, if we have too many pairs, add an edge, then go down. And I've checked the extreme cases. So it seems like it would be good. Alright, you have a communication channel with n plus 1 stations. Station 0 wants to send a message to station n. You may install memory disks set up to k of the stations. Okay, let's denote the increasing sequence of stations at which memory disks are installed by the sequence. Wrong answer. What? How do I have wrong answer on this? How many other people are getting wrong answer? Well, what's happening then? Oh, it just must be different. Parallel edges are not allowed. I mean, yeah. I don't understand. So we have 6 nodes. And it's a star and everything's happy, isn't it? Exactly 4 unordered pairs of nodes at distance 3. Is it some stupid case like n equals 2? I don't understand. Like, k has to be 1 when n equals 2. Like, the only possible thing is to print 1 and 2. Max is that otherwise. So, for example, with 3, you can only have this. There's only going to be 1 pair. And if we want 2 pairs, then it's not possible. If we have 2 pairs, then it's not possible, right? So we have something like 1, 3, 2. It's not possible. I do not understand. Am I repeating edges? I couldn't. J equals I plus 1, j is less than n, j plus plus. So 1, 2, 1, 3. No zeros in a valid case, but we could still try. Then 2, 3. Right, now that makes a cycle. Oh wait, that is a problem, huh? Wait, so with n equals 3, we can make a cycle. And therefore all nodes are 1 distance apart from each other. Wait, does that extend anywhere else? Is that just some special case we have, or is this something more significant? Oh wait, actually, with a complete graph. Oh, with a complete graph, then we have a problem. Okay. So the n equals 2 case kind of generalized, and I missed that. Huh. So with a complete graph, for example, like here, then we can get exactly n times n minus 1 over 2. That's fun. But then, but say we have a non-complete graph. So for example, we have this, except, like, there's at least one edge that doesn't exist. Then therefore, there's at least one node that's of distance 2 away. And therefore, we have the same argument with this. So I guess the special case is that we have a complete graph. So if k is equal to n times m minus 1 over 2, see out that's fun. So that's a special case. But is it the only special case? Okay, I didn't consider diameter 1. With diameter at least 3, then like there are multiple nodes that aren't involved, so I'm pretty sure it's not possible to do better. Okay, but diameter 1 is a special case. Because otherwise, with diameter at least 2, there's at least one node that can't ever be part of a longest path. Or how would that work, actually? Yeah, because the way the diameter works, like there are two things with longer paths in it. So if it's part of any longest path, then the path from one of these nodes to this would actually be longer, so that wouldn't be possible. So I think complete graph is a special case, and it's like the only special case or something? I don't know. Let's do something like 4. So 4 and 6, 4 and 5, 4 and 4, 4 and 3. So 4 and 6 is a complete graph. 4 and 3 is the star graph. Other than that, I don't think it's possible. Because then, again, if some edge doesn't exist, then the longest path is of length at least 2, and therefore we had this argument. Is that right? 7. Let's do all cases. Or 6. 4, 6, 4, 5, 4, 4, 4, 3, 4, 2, 4, 1. So, complete graph, not possible. And then we have a star, and then we have a star with 1 removed, and then we have a star with 2 removed. Okay, I don't know. I can't think of anything else. Then again, I also couldn't think of anything else before. Did I just add another problem? The hell? Okay. New channel with n+1 stations. 0 wants to send a message to station n. Okay. Well, we got that. Cool. So I guess that's that then. Now the next move is XOR counting, or is this some sort of FFT problem that everyone finds trivial or something? Yeah, it seems like everyone got stuck on this case, I guess. So that's fun. Oh god, it's FFT, isn't it? Find the number of sequence with k elements which satisfy the following conditions. Every element is an integer between L and R inclusive. The bitwise XOR of all elements is between A and B inclusive. So that's fun. Great. Who solved this? Tourist, maybe? Oh, huh. Could again just be some sort of FFT style problem. I'm not exactly sure. What's this problem? Triangle free graph. Oh god. Oh god. Okay. I'm gonna read the problem that seems most reasonable, and to me, at least now, that looks like not that one. Okay, I'm in 7th right now, it's pretty cool. Although the penalty wasn't that great, so other people could definitely overtake me later, like all of these people. Yeah, that gave me an hour penalty. So like everyone here could probably beat me if they were able to, or if they solved that problem. So in terms of rank, it's not perfect right now, but it's fine at least. So we'll come down to the later problems. Damn. We could have gotten less penalty, but whatever. So let's try this one. There's a communication channel with n+1 stations numbered 0 through n. Station 0 wants to send a message to station n. You may install memory disks at up to k of the stations 1, 2 to n-1. Let's denote the increasing yeah. So where are the memory disks? And let v0 equals 0 and vk plus 1 equals n. Okay. And stations other than those, it is only possible to send the message forward without storing it for later. Stations other than those, it's only possible to send it forward. So I can send it to I+1. What the hell? With probability pi, the transfer succeeds and the message reaches the station I+1. Otherwise, the transfer fails and the message instantly goes back to the station Vj. Let me guess, everything's huge. N is 10 to the 5th, k is 50. Interesting. What do I print the expected value? Is it it's the doubles? Okay. You're not given the probabilities directly, instead you are given a non-increasing sequence. Why would it be non-increasing? Oh. That's so weird. Why would they do it like that? Why would they do it like that? So if we could figure out some sort of DP, then it would be simple, right? Like it's, each range is independent, so it's the sum of the expected values of each range. Which is to say, yeah. So they zero index it for some reason, which is just even weirder. So is it a DP kind of? How this works? So if you let let's see, let dp of I and j be expected value of being at I with j disks. Then how would this work? Somehow we have to crack the formula for a range, then we can optimize that with a segment tree or something. I think maybe something like that would work. It's not necessarily what we're supposed to do, but something like that would possibly work. Okay, still eighth, not terrible. Especially because there are more 7 stars participating now, so it might be less easy to lose rating, I guess. Because last time, like, I had some pretty good ranks, like 13th, and that almost took me out of red, which is kind of sad. Okay, so dpij is the expected value of being a j using or expected value of being I having used J disks. So then the answer would be dp of n and anything. So obviously J is less than or equal to K. K is at most 50, which is fine. This F thing is interesting because it's kind of like it's just interesting. I feel like it's important somehow, or maybe it's just so that the probability isn't so terrible. Alright, okay, wait. I feel like there's been some problem before. I think this has showed up before. Like something like this. Yeah, that's exactly what this is. So this is saying either you... So this problem I found, beautiful mirrors, basically says, like, at each point you have, like, some probability of going forward, and otherwise some probability of sort of resetting and going back to the beginning. Which is, like, exactly what this is. So, like, let's look at their formula that they have, because, like, why not, right? What is this one? This one has checkpoints, so that's even more interesting. Oh, I see. I see. Pretty sure we can just like apply this and just be done. Like we apply whatever this math is and then figure out how to do this. So PI would be the probability that the ith mirror will answer yes. Yes, sure. Is that not what it gave? I mean, yeah, that's exactly. It's just the statement. Okay. Oh, I see. Okay. Divide by 100. EI is the expected number of days until he becomes happy. Right. Then by the definition of expected value, EI equals 1 plus PI times EI plus 1 plus 1 minus PI times E1. When initially he is at the ith mirror. That makes sense. Okay. So then this is 1 plus P1 plus P1 P2 plus P1 P2 P3. Okay. This is this is not dirty. They gave a problem that's been seen before. It's fine. This is their own fault, not mine. So like that's exactly what this problem is though, right? Like either it goes to the beginning or it dies. And so the idea is you want to build a segment tree on it. That's what they did for the other editorial, right? Maybe not a segment tree, but they like... Is it a segment tree? That's like some weird thing where they maintain some prefix sums or something. Okay, so they say the formula is E1 is equal to... So you solve this system of equations. So all we need is E1, because then we're interested in, like, say the last thing we put is here, then essentially, if we're trying to figure out what it takes to get here, it's sort of just like going over here and finding the probability of succeeding with this as the starting point. So it's solving the beautiful mirrors problem with this as a subproblem. This is the starting point, and this is the ending point. So that's exactly what we want. So we let let's see. So the value is E1 equals 1 plus P1 plus P1 P2 plus P1 P2 P3 plus P1 P2 P3 P4 etc. ... plus P1 dot 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 Pn, right? N minus 1. Oh, I see. N minus 1. All that over P1 dot 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 Pn. Right. So that's where this 1 comes from. It's essentially this up here, I guess. So then when we stick a new thing on, so when we have a new element, we add on to this, we add on P of 1 dot 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 Pn. And this becomes P1 dot 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 Pn plus 1. Right, okay. So this is how much it changes. So essentially, if we stick on a new element, then we get like, it's sort of like f of n or something is equal to f of n minus 1 plus like this quantity, Pn. Actually, this would be up to n minus 1. And then we would stick this thing on. Actually, wait, let's like define the notation better. F of n plus 1 is equal to f of n, which is the E1 value here, plus P1 dot 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 Pn over P1 dot 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 Pn plus 1. And this sort of f of 1, this sort of f of n will also be divided, wait, okay, hang on. So this sort of changes, the only thing that changes is we get an extra Pn plus 1 here, which means that f of n, this recurrence is only over Pn plus 1. And at the same thing here, suppose the idea would be that what would be the idea? Do I have test cases for this problem? There better not be. Please tell me there isn't. Oh my god, there is. But the sum of n is at most 10 to the 5th. Okay. So it's f of n over Pn plus 1 plus this and that. Which is essentially the same as f of n plus 1 over Pn plus 1. So what we want to do is do this with a segment tree. That would be how it works. This is messy. This is for sure messy. It's like not that bad, is it? So we get a recurrence like dp of I and j equals the minimum over values k less than I of dp k j minus 1, because we put down a new thing, plus sort of f of like the indices k to I minus 1. That's the recurrence we're working with. What do we do with it? Somehow, like, I mean, sure, that's the recurrence. We can't do it like that. It has to be better. I better have a time limit of more than 1 second. 2 seconds. Okay, that's not great. Not entirely sure what to do here. But as we go from I to I plus 1, what we do know is that we do know how this changes. We get this addition of value. That gets divided by Pm plus... So this whole thing gets divided by Pm plus 1. So we get f of n over Pm plus 1. And then we also gain this addition of value, which is divided by Pm plus 1. So we get plus 1 over Pm plus 1. Question is, how does this help? Somehow this must be optimized. Can we do divide and conquer? Is that a thing? Can we do that? It's just like, can we do it? How does divide and conquer even work again? 1 hour, 47 minutes. We have a lot of time. Wait, did they extend it? Oh, they extended it by 30 minutes. Okay. Cool, so this is gonna be even longer. Yay! Pij equals min. Right. So somehow like this happens. How does this happen? So if we didn't have this part, we could like compose addition and division. We could do some lazy propagation. It would be great. But unfortunately, we do have this part. So let's like figure out how divide and conquer DP works. Right, so one person has solved this, and like, what the hell? Okay. Actually, I'm looking for their time. What's their time? It takes 0.55 seconds. I'm not sure if this is better. Is this true? Could we use this here? It's the problem with not knowing how things work. Yeah, this is the recurrence we have, except like we swap the two things, which is fine. That's not a big deal. Question is like, is this even possible? Does this work? Could also be something like convex hull trick. Just some sort of advanced DP, right? That's what we're doing here. Can we compute the cost function in node 1? We might have to read the editorial for the second version. Yeah, I see. Okay, so we can do the cost function of 1, as they say, with some sort of prefix stuff. Fine. Let's see. So can we do like better? Can we do something else? What exactly is possible? I have the feeling that the XOR problem is some sort of linear algebra stuff, so I really don't want to do that. Instead, I think we should do this one, which seems at least plausible, perhaps. But like, how plausible is the question? Does this even work? Can we prove anything about the cost function? Sort of like as you go along, both the numerator and the denominator gets bigger. Jesus. As you go along, both the numerator and the denominator gets bigger. So, not sure what that would do. Actually, we have this recurrence. Is this monotonic? That's the question. Does this get better as we go along? That I'm not very sure of. Because if we like we figure out some sort of formula for this, f of n plus 2 is equal to f of n plus 1 over p of n plus 2, which is equal to f of n plus 1 over p of n plus 1 plus 1 over p of n plus 2, which is to say goes f of n over pn plus 1 pn plus 2 plus 1 over pn plus 1 pn plus 2 plus 1 over pn plus 2. Should verify that this formula is correct again, just to be sure. You add on that, you do that, and you get 1 over pn plus 1, and the whole thing is divided by pn plus 1. Yeah. So if we extend this, I suppose it would just like keep going. Yeah, like you would just have something. Problem is like none of this is constant. Is this thing. F of n plus 1. This is a probability. So of course this is monotonic. I don't know what I'm saying. Probabilities are less than or equal to 1. So of course dividing by this will make it bigger. Yeah, I don't know what I'm saying. Okay, this is interesting though, because this kind of makes use of this whole like weird array thing we have, where we can do this, which is interesting. How are people doing on this? These are not easy problems. Whoa, Jesus. Is Terrace gonna lose? Damn, like not having a good time. Maybe set queries is easier. I'll try that after a bit. So 1 plus. Alright, so in general we have this sort of thing. The question is it monotonic? So like say we have f of k, or we have f of I k plus f of k j. And it's sort of like this formula. Yeah, it's this formula, but we start at I and go up to k, essentially, is the idea. So, like the thing that changes is going to be the question is, how does this compare to f of I k plus 1 plus f of k plus 1 j? Does it compare at all? So there may even be something better we can do. Divide and conquer just doesn't seem to pan out. Can we optimize it to something else like convex hull trick? So we get some stuff like this. But what I really want to do is to compute f of I n for all I. That we can do efficiently, but then like somehow I want to have it so f of I j with like composed with some function of f of, I may have done the composition wrong, but it's like I want to have it be something like g of f of jn, where j is greater than I. I want to represent it as that. That way I can sort of like inverse it kind of, and The idea is to make it convex hull trick, right? So, how would this work? Is it something like this? So f of I j is equal to this. So if we reduce it by 1, like what's the inverse of this function? So f of n plus 1 times pn plus 1 minus 1 is equal to f of n. Problem is, like, this is too much. Somehow it has to be some like universal formula. But I mean, we have this formula here is the thing. So if we represent it like f of in is equal to pi plus pi plus pi plus 1 plus dot 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 plus pi up to pj plus dot 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 plus pi, or actually pi up to pj plus 1 plus dot 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 plus pn. That's a horrible j, sorry. But then we get all that over pi dot 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 pn. So we could separate it out to, like, I'm gonna move this over so I have more space for myself. Right. How much notes? Jesus. Alright, I'll expand this out a bit. I can move this over even more. Nope. Move this over even more. Alright, now if we separate this into something like this, f of I n is equal to pi plus pi pj dot dot dots excluded plus pi pj plus 1. Actually, this is exclusive of k, isn't it? Yeah, it should be exclusive, actually. So this would be j minus 1. Whoops. And then dot dot dots excluded. Or actually, minus 1 over pi dot 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 pn. Plus, etc. pi to pj plus pi to pn over pi dot 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 pn. So this is f of ij, f of I to j over pi dot dot dot. Actually, this would be because f of ij would be this, and then divided by pi dot 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 pj, right? That's what that is, right? We have this, and then it goes up to n inclusive. Yeah. So this would be f of ij over Actually, let's get rid of the annoying like one term. Yeah, actually, this gets rid of the annoying one term. So it's kind of like, so actually this would include this. My bad. And then this would be pj plus 1. So then this would be over pi dot 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 pj. Yeah, that way we get rid of the annoying one term. And then this is just the same as that, which kind of makes it more understandable. So an f of ij is this over pi plus 1 dot 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 pn plus constant. This is constant. Specifically, all of these terms are a multiple of pi dot 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 pj, and obviously this is 2 dot 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 pj. So we sort of multiply by this, and then we get pj plus 1 plus pj plus 1 up to pn over pj plus 1 up to pn, which is to say is equal to f of ij over this constant. Let's let this be c1 plus f of j plus 1 comma n. It should be f of jn, shouldn't it? Oh, that's sort of inclusive of the last one. Okay, so I'm pretty sure I have the indexing wrong again, and it should actually be this, because this is inclusive. This is inclusive of that. But either way, it's the same thing. And then this would be m minus 1 or something. It doesn't matter. It's just how we define the function. So what I'm trying to solve for is this. I'm trying to solve for this as a function of only other things that are constant. So now we get that f of I j minus 1 is equal to c1 times f of I n minus f of j n, which is perfect, because this is something we can do convex hull trick on. Specifically, f of in is a constant for a given I. F of jn is a constant for a given j. C1 is a constant for a given I. So that's it, isn't it? What's the catch here? This should be this should be up to j plus 1. Or something like that. But C1 is actually some other function h of j, which is fine. Because now we can separate these out. So we get h of j times negative f of jn, which is again a constant for a given j, plus h of j times f of in. And then if we're solving for a dp value, then we would also add on something like dp of like I something. Constant, constant, linear. This is a value of x. This is something. Therefore, we can do convex hull trick. Let's go. I'm gonna get water because I want to be at my best while implementing this. So I'll be right back. So we have this. Set queries also seems like an interesting problem. Maybe we can try that afterwards. Alright, this is going to be hard to implement, I believe. So first I can whip out the convex hull trick that I have. I can find a better one online. This one's specifically geared for doubles, which I'm not sure actually works. Let's see. Okay. I don't understand why this doesn't compile. Why does this not compile? Like I've copied this one before and it just dies. I don't understand why. I guess it does? Okay. So we can do this, 1 over 0.0, turn A over B, long double, long double, long double, double, long double, long double, long double. We have precision of 10 to the negative 6th. Sure. Did unmute the mic, right? Yeah, okay. So, okay, perfect. So everything is double. Let's see if this compiles. It should. What? Const expert. Is that what you want? 1.0 EO over what? Over 0.0 is not a constant expression. What does that even mean? Guess I'll look this up. Constant expressions. Are we supposed to do something else here? It used to be something huge like 1E18. Guess that would work. Why does that not even work? What is this? Huge val L. Guess we could do something like this. Okay, sure. All right, so we have this combinatorial trick, and now we have to do some formulas. So I have to follow my own math, which could be hard. So f of in is something like this. Okay, I have to be clear that we're being exclusive of n here. Sure, why don't we just be inclusive and not be annoying about this? So f of n minus 1, yeah, is that. So first, like, the cool thing about this weird input is that, like, it makes things kind of work. Because, like, f of, let's see, like, p of n, for example, is equal to f of 1 or rather p1, p2, p3, dot 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 pn is equal to f of 1 over f of 0 dot f of 2 over f of 1 and dot 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 f of n over f of n minus 1. So it's like, which is like telescoping, so it just becomes f of n over f of 0, which is quite cool. So actually all of these values are quite easy to do. So if f of ij is equal to this, we want p1 up to pn. LD, what's the value? 10 to the 5th. Why would they have test cases here? This is so annoying. C into n. Now let's see, so this should be f of 1. I plus 1 over f of 0. Num pref I equals r. That should work for this. Now say we want to get up to 3, for example. Then we would get this and then divide by this. Yeah. Let's see. Okay. Right now, what we want to do is dp is almost 50. So dp 0, 0 equal to 0. Now, the way this works is maybe this is easier doing it like this. Pref 0 equals 0. Yeah, that might be easier. Okay, we'll just one index. So then dp I 0 is equal to, how would this work? It would be, we can do it like this, 52, that would make it slightly easier. 0 I is equal to what? It will be, it would be P1 plus P1 up to PI over P1 up to PI. This doesn't make any sense. It should be this. Yeah. Then this would be like the prefix up to this. I understand now. What would this be? This isn't exactly perfect. Wait, we do need the 1 here. Okay, I kind of messed that up, but -1. This indexing is going to be so hard. Maybe we include this here. So if we're looking for f of I, then the first one's going to be 1 over P1. The second one's going to be 1 plus P1 over P2. Over P1, P2. So 1 plus num_pref I minus 1. Is that how that works? Over, then it would be f of I plus 1 over f of 0. Let me just sanity check myself, make sure this works at least here. 4 and infinity. That does not make sense. Now this should be I. Still doesn't make sense though. So the probability of getting to 1 is that. The probability of getting to 2 is 6. That's what we expected. Okay. Now, for LOJ equals 1, J is less than or equal to K, J plus plus. This is where the hard part begins. LD ants equals so the maximum possible answer would be like n divided by 10 to the negative 12th. So I think 3e18 would work. I equals 0, I is less than or equal to k. Ants equals min, ants dp I n. Let's see. Fixed. I'll do like 12. Cout ants and now we figure out this. dpji equals 1e18. Now, I should probably just start at j. Yeah. Otherwise it doesn't make sense. Start j minus 1. Actually, it doesn't matter. It's a constant anyway. So, let's see. We have to compute this right. So this is, so it's the prefix of I. Like 1 plus pi. This is something like 1 plus pi plus pi I plus 1 plus pi to I plus 2, etc. all over pi to n. Or this would be j. But we only care about n, which is fine. Pi dot 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 n minus 1. So essentially we subtract out so all this would initially be P of 0 . So let's make this n. Is it true that the only values we care about are suffixes? I guess so. Yeah, I think it would be. So the only values we care about are suffixes. Start. So then it would be like, where is this? Can't find my own notes. Okay, we're here. P1, Pi minus 1. We can also rely on this. This would tell us the formula. It's P0, P1, Pi plus 1. Right, like initially we have 1 plus P1 plus P1, P2, and so on. So we want to subtract out all of that. We have P1, P2, and so on. So we want to subtract out all of that to get only I. So L out num equals num pref n, num minus equals num pref, what would it be? Start? Let's start. This would be n minus 1, which would be exactly what we want, and then we subtract out start. So if start is 0, for example, then we include everything. If start is 1, we don't, etc. So that's the numerator. Let me add 1. Yeah. So then we then what? Then we have Pi. But this is also like P0, P1, Pi minus 1. Which is kind of exactly what we want, isn't it? Should not include that. If start is greater than 1. Start is greater than 0. Right, T will be prepared where T equals P1. Yeah. So we divide by SU minus 1 both times, which means we can kind of just not do that. Num divided by equal to let's see. So this would be f of n over f of 0, the probability of the whole thing. Yeah. And return num. Right. Should be 2 and 6, right? 4 and 6. Or 6 and 2, actually. Wait, it's getting 4 and 4. Zero and 1. The numerator is 1. How is the numerator 1? Don't exactly understand. So this should be 2 plus 4. Should be 6. Don't really understand. What's happening? What's happening here? Why is this happening? What is happening? What is happening? This is 1/2 plus 1/4, I guess. Yeah. 1/2 plus 1/4 plus 1. I don't understand any of this. What the hell? I really don't understand those, why that's happening. So, like, what is this? Start, num, etc. It's like 0.5, which is just that. So if I make this n, does it just work? No, it doesn't. Okay. It's 0.75. Multiplied by 4 is 3, which like doesn't make any sense at all. 1.75. Let me like subtract out the start. What is going on? Come on! Why is this so hard to focus on? God. So num prefix of n minus 1 is like it's like the first one. So n is 3, so this is 2. And 2 is like the first 2. So it's P1 times P2. Actually, it's P1 plus P1, P2, which is 1 plus a fourth. This should be 1 plus P1 plus P1, P2 over P1, P2, P3. But there's only like 2 probabilities. Oh wait, n is 2, right? So it's 1 plus P1 over P1, P2. So why is that now 1.5? Why is it now 1.5? It should be at 1.5. Why is it not? What is num prefix of start? Should be 0. Start. I'm so confused. How is this not? How is it not? How is this not? What is this? What is this? What is this? So num prefix of start is literally 0. So what? How is num 1? Oh my god, wait, is that it? This whole time it's been long? It has, hasn't it? Oh my god. Okay. Well, yeah, that's force of habit, I guess. Alright, but that's wrong somehow. That's wrong even though it shouldn't be. It's because the 1 is like separate, I guess. The 1 is separate. Num plus equals 1 over, what would it be? F of n over f of start. Six, 2. 1, 2, 1, 9, 3, 1. So then this should be, so it's 1/3 each, which means it should be 3 and 9. Or it's more than that. It's 3 and then like, what would it be? It should be 1 plus f of 1 over f of 1 times f of 2, which is 1 plus 1/3 over 1/9, so it should be 12. Okay, 12 and 3, cool. So I guess this is right. Or we could do something like 1, 2, 1, 6, 3, 1, which would then be 1 plus 1/2 over 6, which is 9. Yep, 9 and 3. Okay. Cool. So now this is right. Now we have to figure out the rest of this. What is h? What did I define as h? I don't even remember. Right, I said it was some constant. Like this is C1. Specifically, it's Pj to Pn. So LLH equals f of n over f of I. Although cur equals negative h times get f I. Let's just make that clear. Start equals m, return 0. Cur equals negative h times that. I is greater than 0. Now we query LC dot query, and the value is h. Then dpji equals qv. I is greater than j. It should be like this, right? Yeah. I is greater than or equal to j. That lets you put in the line. Yeah, okay. Now, if I is less than n, now we put in the line. And the line is f of in, LL m equals get f in, and LL b equals dp j I. No. What? J minus 1. Right. dp j minus 1 I. Then LC dot add MB. Supposedly this works. But it doesn't. No, because I don't even need this. What else? Get F QB plus cur. Supposedly it should be 4. It's not. C out J. Supposedly this is right. How would that be 0? So if IJ is inclusive, that means it'd have to be like something has to be J minus 1. Have to be F of I J minus 1. So right, J is equal to the current value of I. So this is like up to J minus 1. So this should be that, I suppose. Wait, that doesn't make sense. This should be I minus 1. Something's like messed up here. Wait, does printing it change the answer? Oh no. Come on, seriously? Okay, good. Have that bad of undefined behavior. So this is f of in, whatever that would be. This is negative f of jn, or something like that. And that's dpij. So I don't understand now. What's wrong with this? There should be j. That 1 is like annoying though. That 1's just there. I think the 1 is the problem. Where does this 1 come in? Like, this is like minus that 1. So this is something like that. So then we include this in here. So that's like plus f of n over f of I. Something like that, right? I have to include that, even though it's like always consistently annoying. Now that would make that necessary here. Why does it not change? Why is it not changing? What the hell? Don't understand one bit. So m is 6, b is 0. Why don't we just be normal? Didn't change anything, but it's more sane to do. So I get 1, 0, that's expected. 1, 1 should not be that at all. Somehow this is like too low. So the value of h is f of n over f of I minus 1. What have I done wrong? Am I doing the code wrong or the math wrong? That's also a question. So h of j times f of in minus f of jn. Like also plus that. Wait, maybe it's something like this. So that's significant. Doesn't change anything. How does it not change anything? It's literally adding a value. How does it not change anything? I'm so confused. It didn't change anything. So 0 and 0. Oh my god, every time. I'm using long longs here. Am I using long longs anywhere else? Any other problems? Yeah, this should be, oh my god. Oh my god. This is long double. That should be long double, that should be long double. Everything here should be long double. The fact that it wasn't was concerning. So now I get 3.5, which makes even less sense. How is this 1.5? So QV is, H is 0.25, which is expected. So 0.25. Get f of I is 2. Okay, that's actually expected, right? But then the line is messed up somehow. So QV is 1.5. I don't know what that would mean. Where is this formula messed up? So we have h of j times negative f of j of n. F of 1 to n should be that. In fact, it would be the same as this, which, does that make sense? We're looking for f of 0 to 1 somehow. dp of that is 0. So this should be h of j times f of that. Like, it's just somehow messed up. Pj plus 1 pn. J minus 1. If I take this part out, does it fix things? I feel like it wouldn't. I feel like it'd still be wrong. Yeah, that makes it even more wrong. Does multiplying by 2 offset the fact that we use the 1 here? That doesn't even make sense, but... Okay, it makes that right, and it makes the other one right. Oh no, does it make sense everywhere else? Let's try something like 6. It makes it 5. What am I printing? Do something like 6, 3, 1 should still be 5. Okay, so that doesn't work. So it should definitely still be 5. So something's like wrong here. It's making it undercount. So we have f of in is this. It's 1 plus pi plus all that up until n. This will go to j minus 1. What we're really interested in is j minus 1. J minus 1. And this is just j. Actually, then this should be j minus 2 or something. Right, so then pj, j minus 1 should actually go here. How would that work? If we want it to be... It's supposed to not include that. So it's also kind of like subtracted out this part. J minus 1 over pj, pn. Is that what we need? That might be it. Plus f of j, no, I minus 1. How'd this work? So this goes over here. And this goes up to j minus 1. Which is a problem. Because this part kind of gets ignored. Actually, it would be PIPN. Wait, so this should actually be 2 times this. Shouldn't it? It actually makes sense that this would be 2 times this. So what's wrong with this one? So 2 as expected, and then some other problem. What are the lines we're putting in? Or actually, rather, what's this? How do we get to this value? So we get 3. 3 is what we expect. Then this is like h is 0.3, sure. Get f of I should be like 0 because we're already at n. Should be 1. Is that how we define this then? Makes it worse. Why would that make it worse? What? Oh my god. What the hell? What is going on here? Why is this so annoying? I get 1 that. It's sort of abstract. So do we end up not needing either of these? I'm actually very confused right now. Wait, this should fill it in actually. Because this is like, this becomes the 1 on this side of the equation. Yeah, it becomes 1 over PJ/PN. So neither of these should be necessary. So why are they? And that doesn't work for the sample again, so we'll use that. I'm not sure if I'm going to get this problem. God, it's so annoying. So we get 3 here too. What the hell? So QB is 1.5. Negative 0.5. $1.5. Wait, what? What happened? Oh, they messed up the, okay, the things, because it's like time. Okay. Well, so 1.5. Which querying f of, so h is 0.5, h is 0.25. Wait, here it should be, h should be 0.5. How is h 0.25 here? Is that part right? No, this should be PJ now, shouldn't it? I'm so confused. How? How? God, how? I need -0. What the hell? So cur is, what is h? Okay, so we have 3. Okay, actually, so QB is 6, which is fine. Should this be 1 now? Maybe it should be. Makes it 5. I just don't understand. So 2 is the right answer for that, and this doesn't make any sense whatsoever. I don't even know how you get 9 as a query value. This doesn't make any sense. Or maybe we want the, is it that we have to query the minimum instead of the maximum? Does that make the difference? Does this make the difference? Maybe it does. Maybe it does make the difference. 5, 4. Huh. I always forget to do that. I always forget to make the convex hull trick, like query the minimum instead of the maximum. Okay, so 1, 2, 1, 9, 3, 1 should be 6. 1, 3, 1, 8, 4, 2, 1. So it should be 8. 1, 3, 2, 8, 4, 2, 1. 1, 3, 1. So see something like 10, 2, 2, 1. So the best place to put it would be at 5. So then you have 1 plus 1 over 2. So 4. So the answer should be 9 or 8. Okay, wait, how? How exactly? Where does it put the thing? It would be 1 plus, how do we get that? I'm not sure if it's correct or not. 3, 1, 10, 2, 2, 1. So that would be 1. then this would be 1 plus 1 over 1/2. So the half chance you're done in 2. There's another half chance you're done in 4. There's another half chance you're done in 6. Why is that not 4? That seems like a problem. I don't even understand what this would be. Should be 4. So where's the partition? So 10, 2, and 2 would be... Oh, I see. Okay. Yeah, that works then. That makes sense. Fine. So then we'll do one more. Something like 1. Also, things reset, right? Number prefix is just set. F is an input, and DP is... like, yeah, okay. 1, so 4, 2. And it'd be something like 16, 8, 4, 2, 1. And this should be 10. Okay. Well, seems like it works. Seems like it works for small cases. I'm not sure if it would work for the better ones. I mean, problem is not visible. It's still going on. So it's like 1, 4, 2. Can do something like 24, 8, 4, 2, 1. And the answer should be 11. Yeah. I can do 32. The answer should be 12. We got it. Oh, wow. Okay. Man. Alright, well, in 10 minutes, I can't do the last problem. So, what rank do we have? Something non-terrible, I hope. Where were we? So where am I now? 13th. Okay. Well, I got this one. Proud of it. Okay. So, yeah, well, that took way longer than it should have, honestly. It was just sort of bashing out math formulas and then struggling with the code. And it turned out the biggest part was that I had to make it so it was querying the minimum instead of the maximum, because that's how COMMCHA works. I guess I can... Actually, what I'll do is I'll read the Div 2 problems now. Because there's no way I'm going to be able to get this one in 10 minutes, right? I can't even read the statement in 10 minutes. So blue provides light. Yeah, there's like no way. Okay. So we end up with a similar rank that we've had like the past couple of times too. Rank 13. Oh, set queries is that? Alright, well. Whatever. Wait, did they put the wrong problem in? Or did they just... Oh, they put all of the things here? So chef and IPC, flip the string. Hiring workers, graph instruction, set queries. Interesting. So they just put all the problems in div 1. Or div 2, I guess. Alright, well, I'll go over the solutions to the ones I could solve then, I suppose. I got 5 problems overall. It was not terrible. Also wasn't great, but it wasn't terrible, I suppose. Let's see. If I hadn't spent so much time on this, probably could have done something better with this, perhaps. But I'm not entirely sure. I mean, it took a long time, for sure. It took a long time to get the convex hull one, but other than that, it was, like, pretty fine. Could have been faster, could have had fewer penalties, but it's fine. Interesting. So for the first time in, like, forever, Turris is going to be second. Like, look at this streak of rank 1s he's had. It's crazy. How much rating would he lose for that? Jeez, it's gotta be harsh. Alright, so they put the Div 2 problems in Div 1, which kind of explains how all of that came about. Okay, I'm going to open a new Paint tab because I want to save these notes for my explanation. There's no way I can rederive all this stuff on the spot because it took me an hour to do it the first time. Okay, right, so here's what we're doing. I'm going to go over the solutions to the Div 2 only, or just like all the problems I solved, which is the first 4 and the 6th one. And then I suppose afterwards we'll see how rating goes and stuff. So there were, wait, actually, I'm kind of interested. There were 26 pages of participants this time. Will this knock me out of red? I'm not entirely sure. There were 26 pages of participants. There were 34 this time. But there were way fewer 7 stars. And so of the 7 stars, I did relatively bad. But this time, there are way more 7 stars. All right, Timmy, good job. Yeah, so like, I don't know. I don't know how rating will go, but I guess we'll see. We got rank 13 like last time, I suppose. That's just how it goes. Can't do better, can't do worse. Alright, so we have this thing. Essentially, there are a bunch of students. Let's list each student as a line. Oh, and this is IPCCERT. There are a bunch of students in a line. And there are also a bunch of lectures. So each student watched each lecture for a certain amount of time. So we have this sort of matrix where this student watched this lecture for this, and etc. 1, 2, 4, 7, 9, 9, 1, 1, 1. In addition, there's this other metric that says they basically they asked like a certain amount of questions. So like, for example, they asked like 3 questions or 4 questions or 5 questions or 10,000 questions. And so so you want to count like the number of eligible students for getting a certificate. So to be eligible for getting a certificate, first you have to have asked at most 10 questions. So the number of questions must be less than or equal to 10. So therefore, automatically this student is invalid because they asked more than 10 questions. And also the total lecture time, the sum of times must be greater than some value m, where m is given. So for example, let m equals 9, that works? Yeah. So then we check, so like the implementation is just checking for every student whether they're eligible. So first, sum up their lecture times, which basically just says, like, read in all the values and take their sum. Now, if that sum is less than m, then they're automatically invalid. So for example, we would invalidate this one. And then read in the number of questions they ask and check if that's also less than 10. And if not, then they're invalid. And so, like, we would invalidate that one too. And then you can print n minus the number of invalid students, or you can say if a student is valid, that is, they're not invalid, increment some counter, and then that would let you do what you want. That would let you count the students. Okay. That's basically it. It's just an implementation problem. All right, so this is the second problem called flip. And essentially, you have 2 strings. I'll make one of them red, and the other will be blue. 0111001. Why not? And basically, in one move, you can pick a substring of odd length of the first string, and then flip all of their characters to the opposite. So for example, this would become a 1, this would become a 1, and this would become a 0. Your goal is to make the two strings equal in the minimum number of operations. So what is the minimum number of operations? That's what you have to find out. So basically, like, you don't care really about the values of the strings themselves. You care about whether they're equal or not. So for example, having a 1 0, having a pair of 1 and 0 and a pair of 0 and 1 is equivalent. The point is they're not equal to each other. And the same for 1 1 and 0 0. So we can sort of create this new string that represents whether each character is equal or not. So this, they're not equal here, so we have a 1. They're not equal here, so we have a 1. They're equal here, so we have a 0, 1, 0, 1, 1. And you can think of this like XORing the two bits together. And so if we consider these as binary numbers, this number would be their XOR, because it's the positions where they're not the same. That's one way to think of it. So now essentially what we want to do is we can apply the flip operations to this string, because flipping a bit will change its state of equality. If it was equal, then it will no longer be equal, and if it's not equal in the first place, then it will become equal. So it's this flipping a bit on this string is the same as flipping a bit on this string. So therefore we can do the same operation. And now our goal is to make this string into a string with all zeros, because then all of them will be equal. So imagine like we didn't have this weird odd condition, and in fact I misread the problem to be like this. Then essentially like break the string up into these groups of ones, and then essentially in one operation the number of groups will decrease by at most 1. Because like say you include multiple groups, but then like every group between the other groups will then become a group. So like you'll get rid of the two groups on the end, but then you'll like add some groups in the middle. And like no matter how it's configured, it's always going to decrease by at most 1. And if you have it so you only remove a single group, well then you'll only remove a single group. But no matter what, you can prove that in any operation these number of groups decreases by at most 1. So therefore, it's just the problem is just to count these numbers of groups. But this doesn't work because you have the weird odd condition. But notice that like the weird odd condition is like not actually that weird. Like if you pick some string of odd length, basically you can only process characters at odd indices together. And you can only process characters at even indices together. So it's sort of like solving two problems independently. Solving for the odd indices and solving for the even indices. So at this point, what you can do in terms of implementation, convenience, is like take the strings at odd positions and make a new string out of those. So this is the odd string, these 4 odd characters. And you can make a separate string out of the even characters. And then now you just want to find out the groups of ones in each of these and sum them up, because odd and even are independent of each other. So that's essentially what this problem is. Make this string representing whether they're equal or not, then the operations are the same, then break them into odd and even strings and solve the problem for both of those, which is just the number of groups of ones you have. Oh, and also like with the proof, you can lower bound the number of required operations as the number of groups of ones, but obviously it's an upper bound too, because you can just remove a group with every operation. Like just have it only be a group and then flip all of them to zeros. Okay, so we have hiring workers. How did my rank change actually? Nope. What is my final rank? Still 13th. Okay, so I guess that's all it is then. Interesting how this penalty works out. I guess a lot of people, oh my god, 10 hours of penalty. Did he like start? When did he solve the first problem? Oh, was he going for the later ones first? That was his first, wow, okay, yeah, interesting strategy. Can't say it worked out, but it was interesting. So we end up 13th. So again, we solve 5 problems, which is interesting. and whack. Yeah, okay. I wish I had read this because it seems it was easier, but I ended up getting this one at the end anyway, so it was still cool. All right, so this problem is called hiring workers. I got a wrong answer on this because I was dumb, but essentially the idea is you have k numbers. You want to pick these k numbers so that their least common multiple so first of all the numbers must be greater than or equal to 1. And their least common multiple must be some given value, what is it, x? X, yeah. And you specifically have k numbers. So how do you do this? Well, first you can prime factorize x. So you can represent x as some sort of like product of prime powers. For example, 2 to the 2 times 3 to the 7 times 5 to the 124th, and so on. And then you can represent the number like that. And then notice that like there's no reason to have any prime power be part of more than one number. Because like say you have a 2 here and then you have a 2 to the 2 here. But then like you can get rid of this and it'll reduce the sum because the LCM will be only dictated by this. But also notice that like you can't spread out the prime power. Like you can't have this and this to get the LCM of 2 to the 2 because the LCM is, for a single prime, it's the maximum over all of the powers for each number. So like you have to have some number be divisible by 2 to the 2 and some other number or the same number must be divisible by 5 to the 124th. So essentially these numbers are kind of grouped together, like with each other. So now you have these 3 numbers to assign. And essentially it's kind of like assigning these numbers to each of the slots so that the total product of them is x and their sum is minimum. So first of all, like let's do a bit of math here. What's the maximum distinct prime factors we can get? Well, the first 7 primes are 2, 3, 5, 7, 11, 13, and 17. So let's take their product. Times 7 times 11 times 13 times 17. So it's 500,000. So if we were to add on any other prime, then we would get a number that's bigger than 1,000,000, which would be invalid. So we can have at most 7 distinct primes. And like in a similar manner, we can have at most 7 distinct prime powers. Which means that like at the worst case, we're only going to need, we only care about at most 7 numbers. So even if k is huge, k can also be 1,000,000, we can kind of ignore all the other numbers, and we can only focus on the first 7. Or if we have less than 7, we'll have to solve for that. But we only care about at most 7 of the numbers. So now at this point, there are a lot of things you can do. No, 7 to the 7th. You can do some sort of brute force where you just literally like brute force which number each of these goes to, then take their sum. That works. And in fact, it's probably the simplest way to go. What I did was I did a bitmass dp, which is stupid, but it's basically like you let dp of I and mask be the minimum product, or the minimum sum, having used the first I numbers and like you have this mask of the primes that you've already taken, sort of. All right, if you don't understand bitmass dp, just do the brute force. It's simpler. And in fact, it's like 40 times 7 to the 7th, which is like 7 to the 7th, which is totally fine for the time limit of 1 second. Yeah. But if you want to learn, if you want to see the bitmass dp solution, it's basically you have the first I numbers and you have a mask of primes that you've already taken. Then the transition is just like take more primes or don't. And then you add that to the sum and you continue. And then the answer is dp of n and, or dp of k and 2 to the number of prime factors minus 1, which is the full mask, that is, all of them have been taken. That's what I did. If you want to see the code, I will link it in the description. But that's how the bitmask DP works, essentially. Again, there are a lot of ways to do it. Apparently greedy does not work, and it's probably disprovable, so don't try that, or I just implemented it wrong. Alright, what the? So this problem is called graph construction, or more appropriately, KDIAMS, which is k diameters. And essentially, you have a number n, you have a number k. You want to construct a graph with n nodes, so for example, say n equals 4. Such that the number of diameters, or the number of pairs of nodes that are a diameter apart from each other, or the number of pairs of nodes that are diameters is equal to k. So for example, like here, oh, and also has to be connected. So for example, here the diameter is 2. The longest path between any two nodes is 2. So therefore, the number of pairs that are diameters are, we can take this one and this one. We can take this one and this one. And that's it. So we have two pairs of nodes that are diameters. K can range anywhere from 1 to the number of pairs of nodes, which is n times m minus 1 over 2. So like the first thing to consider is, this is like kind of an edge case. So if we have this, then we can make a complete graph that is like all of the edges exist. And therefore, because there's an edge from every node to every other node, then the maximum distance is just 1, because for any pair, you can just take that edge and be done. So therefore, the number of pairs that are diameters are all of them, which means that like you have n times n minus 1 over 2 diameters. So that's one case. Case 1 is where you have k equals m. K is specifically equal to n times m minus 1 over 2. So another special case is where you have n equals 2, and, well, it's always possible, because this value is always 1. 2 times 2 minus 1 over 2 is 1. So this value is always 1 when k equals 1, or n equals 2. So therefore, you can just make this like singular graph and be done and be happy. Otherwise, there's the main solution. So consider a graph that isn't complete, because we already handled the complete graph case. So therefore, there's some pair of nodes where there isn't an edge between them. Think of it like this, for example. There's some pair of nodes that don't have an edge between them. And therefore, their shortest distance cannot be 1, so it must be at least 1. Okay, so let d be the length of the diameter, then d is, or it's not at least 1, it's greater than 1. Or, which is equivalent to d is at least 2. So now let's see what happens in this case. Well, indeed, what does happen? Well, we can represent a graph like this. We can represent it like having its diameter as sort of a line. And then all the other nodes kind of just like branch out from these 3. Because this is the longest path. And you can represent any graph in this form, actually. But in terms of a diameter, this turns out to be really useful. So for example, let's convert this graph. So this is going to be the chain we have. And then therefore, there's this other node that attaches to all 3 of them. But the diameter is this. And it's also, actually no, that's it. So then look at the node in the middle of this chain. It has a node to the left of it. It has 2 separate nodes adjacent to it that are part of a diameter, which means like if this node was part of a diameter, then like there would be some path that doesn't go through this, because if so, like it can't go through these. It has to be the end of a path, right? We're considering a pair where we're considering a pair that forms a diameter where this is one of the ends. So if it were to go to here, it wouldn't be a diameter because you can go like extra to the other node. You would have extra distance there. So like it's not possible to do that. So if this were to be a diameter, it would have to branch out somewhere else. For example, here. So you have this chain of length 3 or so. But then like again, you have other nodes on other sides of it that are like adjacent to it. So if we claim that this is the longest path, like it just isn't, because we can extend it one more by going to this node. So there's no path that exists where this can be the longest one. So what I'm saying is that if the diameter is at least 2, then there's at least one node that can't be part of any diameter, which is sad for that node, but it's true. Which means that an upper bound on the number of k we can represent is the number of pairs of all of the other nodes, which is we have n minus 1 nodes and all of the other pairs of those, because this can't be in any pair, so we have only n minus 1 nodes we can make pairs with. So specifically, we have n minus 1, n minus 2 over 2, which means that if k is greater than this value, and it's not this, and n is not equal to 2, then it's automatically impossible. That is what I've proven. Now, this is like a very obscure thing to prove. Why is this helpful? Because it like the rest of the solution, it just like hinges on this. So the idea now is we can get exactly this number, right? And the way we do that is just we make a star graph. We put a single node in the center, and then everything else is adjacent to that node. For example, here. Now, this node will form a pair with every other node, not the center. So will this, so will this, and so will this. Right, so we have exactly this many pairs. We have n minus 1 nodes, and we make a pair out of all of them, so it's just this. By the way, this is also n minus 1 choose 2, which just makes sense. So then, like, what we do from here is, all right, so we can achieve our upper bound. And so I got this idea by kind of just like looking at the sample and like, whoa, that looks cool. And like, look at this, like this path from 2 to 1 is gone because of this edge. So what if we applied the same idea to here? Say we wanted, right now we have 6 pairs, 4 times 3 over 2. But what if we wanted 5 pairs? What if we had k equals 5? Like what we want to do is we kind of want to remove exactly one of these pairs. And the way we can do that is by adding an edge from this node to this node, therefore making the length of this path 1. Now, like, that's cool, right? Because, like, look at this. Like, this is the only path that's affected, because everything else is still of length 2. Everything else still goes through the center. So it reduces k by exactly 1 because it reduces the number of pairs by exactly 1. And we can add as many of these edges as we want. We can add this one too. And then now we have 4 pairs. We can add this one, now we have 3 pairs, and we can have this one, now we have 2 pairs. Simply this one and this one. But say we wanted 1 pair, then we can pick any other pair of nodes and just add the edge between that. So now we've added these 5 extra edges in, and it invalidates all of the pairs except this one. But at the same time, we can add as many of these edges as we want. So it means we can represent any value of k between 1 and this upper bound we have here, which is this. And the reason this is nice is because like the proof I just did before says that the only possible values of k are this. are values in this range. If k is any bigger than this and not one of these two special cases, then it's guaranteed to be impossible because of this proof. So this range of representable values is in fact the only values where it's possible. So that basically proves this strategy works. It works for all possible values, and if the strategy doesn't work, then it's impossible anyway. Therefore, the strategy is correct. And so that's the basic idea. Make this star graph and then add edges between all pairs that that you want to remove a pair from. And then do that until you decrement this number until it becomes exactly k. Note that this doesn't work for k equals 0 because this would make a complete graph, but that's fine because k can't be 0 anyway. And in fact, I just realized that now, and not when I was writing the solution, but it's fine, I got lucky. And k equals 0 wouldn't make sense anyway, because you have to have at least one diameter. So, yeah, I am not excited to explain this last one. This is my final solve, communication channel. And, alright. So I'll go over the problem statement, and then I'll tell you to read the problem that basically gives the solution, and then I'll do the actual solution. So basically you have n plus 1 spots, n plus 1. Actually, yeah, n plus 1. And so you have this message that you're trying to get from here to here, from 0 to n. Yes, this is 0, this is n. So I'll label these here. This is 0, this is n, and everything in between. So in one move, you can try to move it to the next spot. With probability pi, you will succeed. And then the message will move to the next spot. But with probability 1 minus pi, if this doesn't succeed, then it will fail, the message will be destroyed, and the message will be sent back to the beginning. So for example, if you're here, and it fails, then you reset all the way to the beginning. So essentially, you're interested in the expected value, the expected number of turns it takes to get this message to the end. But that's not all. That would be, in fact, exactly the same as the problem I linked. So what you can do is you can add these checkpoints, kind of. I can put a checkpoint here, for example, and I can put a checkpoint here. And then I'll say that when the message gets here, then I sort of save the message. So that if it gets destroyed again, and then it gets destroyed, let's say, instead of going back to the beginning, it will instead go back to the nearest checkpoint. And then now it's sort of different, because it just is different. Because it's sort of easier to get to the end because you have save points. And so you don't always reset to the beginning every time, you can instead reset to a save point. So this is in fact also very similar to the second version of the problem I will link in the description, which is sort of gives away the formula for this. But yeah, it's it also has checkpoints, which is interesting. But it's a separate problem. It's unique enough to be cool. So I won't complain. But anyway, the point is you want to figure out, you have k checkpoints that you can put down. And you want to figure out where to put the checkpoints to minimize the expected number of turns it takes to get the message from 0 to n. Each probability is different for each value, so it's kind of messy. Right. And also important thing to note, k is at most 50. Okay, now we have the problem. Now note that if we put a checkpoint down, then the problem of getting this message over here is independent from the problem of getting this message to this checkpoint. Because once we're here, we can never go back. So, like, each checkpoint creates sort of an independent problem that we have to solve. So the first step is, well, what we want to do is we want to have this dp recurrence. dp of c, comma, I, where we put down c checkpoints so far, and we're at position I. And this will tell us the, it tells us the minimum expected value. So in a sense, this recurrence is simple. dpci is equal to the minimum of values j that are less than I of dp of c minus 1, because we assume we're putting a checkpoint at that place, j, plus some cost function. Let's call that function f. Some cost function for the interval from j to I minus 1. What is this cost function? Well, it's the expected value to get the message from this point to this, provided we have a checkpoint here. So it's sort of like the subproblem for this subarray, essentially. So it would be really nice if we had a way to compute this f function in O of 1. Or just like quickly, right? But even this isn't enough. We have O of n values of I, we have k values of c, and this transition takes O of n. So this is O of kn squared, which is like a problem. So we gotta like not do that. We gotta do better than that. But first, let's just figure out how to do this cost function. And this is where we come up with this problem called beautiful mirrors, which is like exactly this. It's exactly this cost function. Essentially, you have a certain probability of going forward and another probability of like failing. Yeah. And in fact, how many people solved this one? I'm kind of interested. 1,688 people solved this problem. Wow, that's like actually a lot. I guess maybe they upsolved it because it's such a simple formula. But anyway, if you read the editorial of this problem, it just gives you a formula. And like you can derive it by doing some sort of substitution or things and like solving this system of equations and stuff. But essentially you find that you get this formula. 1 plus P1 plus P1 plus P2 plus etc. up to that. If like the probability of advancing from position I is Pi, then essentially you get f of L R, or actually, let's say f of ij is equal to 1 plus Pi plus Pi times Pi plus 1 plus dot 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 plus all the way up to j minus 1 actually, Pi times Pi plus 1 dot 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 within the product times Pj minus 1. And then this whole thing is divided by the product of Pi times Pi plus 1 dot 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 up to Pj. And that's essentially what this formula is. This is nice because it like look at this. This is like a prefix sum of stuff. And so we can sort of compute this in O of 1 with some sort of like fancy prefix and stuff, or some sort of fancy prefix sums where we kind of just like subtract out some stuff. Right? That's what we're eventually gonna do with sort of the math. But supposedly not yet. So this would give us an O of n squared k solution, blindly applying this formula. And in fact, the advanced version of this problem has queries. And so essentially, the second version, like it provides a way to compute this using prefix products and sums and stuff. Yeah. Okay. Actually, I'll leave that open for a minute. So, if you like read this problem in its editorial, it'll probably it'll provide an explanation for how you get this formula. But like the point is, we have this formula that we can use. Right. Now you can sort of derive the rest of the solution from like the postulate of trying a bunch of random things until something works. And indeed, there are many ways to optimize a DP recurrence. One of them is divide and conquer. But it requires this like weird monotonicity condition that I never know how to prove. So I didn't want to try it this time. And in fact, it didn't make sense that it would be true. Or maybe it is, but I don't know. There's another way too, one called convex hull trick. And you don't really need to know much about how it works. All you need to know is that it can optimize certain recurrences. Specifically, it can optimize this recurrence, dp of I, possibly some other parameters, is equal to the maximum or minimum if you negativize everything. Maximum over j is less than I of some value x times dp of j plus some constant that's based on j. So actually, this would be some value of x that would depend on I, or anything but not j. This constant could depend on j, and this value would depend on j as well. And actually, it doesn't even have to... Actually, no, it would be something like... it'd be something like xi times some constant based on j plus dp of j. And in fact, this doesn't have to be dp of j. It could also be another constant. Like, for example, let's call it bj. And then, in fact, we can replace this with a value called mj. And then if you think about this like grade school math or something, this is a line. We have some value x, and we're interested in the equation of mx plus b, like m times x plus b. And then it's the minimum of all of these over, or it's the maximum of these values for this. So we're optimizing lines here, and that's where the name convex hull trick comes from. So it's not that important how it works, as long as you can find code for it. But the basic idea is it creates like a convex hull of the lines, and you can query stuff like that. It's like a lower convex hull, kind of, actually. For maximum, it's a lower convex hull. For minimum, it's an upper convex hull. And then you can query at any point x. This works in O of log n for both operations, insert and... So you can insert a line in O of log n, and you can query a point x in O of log n. Okay, that's cool, but like this doesn't exactly work here. We have this cost function. We have this cost function here, and it's not apparently obvious how to make this sort of thing happen, because the idea is this has to be a constant that depends only on j. It can't depend on I, because then we don't have a line. We have some weird like function, and this similarly also has to only depend on j. But this depends on both j and I. And this is by itself, kind of. C doesn't really matter, because like no matter what, C minus 1 is constant, so we can kind of think of it as optimizing 1D dp. Almost. So we figure this out. So the entire rest of this problem basically is figuring out a way to turn this formula into something that looks like this. Or rather, something that looks like this. We have some value xi and some value mj and bj for each like previous value j. We want to create a line that only depends on the value of x for a specific I. And that's where this like massive, huge page of scribbling math comes in. Me trying to just derive a formula for this. And here's where it ends up. So you write a formula for f of in, like you just write it out. And then sort of, I'm going to actually redo this because it's messy as hell. So you write the formula out for f of in. I comma n is equal to, once again, we have 1 plus p1, or pi. Actually, okay, first of all, the reason I'm doing this as a suffix is because, like, the final form of the formula is going to be something like this. It's going to be some constant that depends on j. Actually, no, I'm going to rewrite it. Because I'm being kind of confusing with my notation here. So, in this notation, I'm going to make j be the previous value. J is the value that depends on the line. And I is the current value that we're solving for. Which means, in a sense, it's sort of constant. In terms of like this context of solving in the convex hull, it's I is a constant. So that's nice. So using this, we sort of think of it like this. So f of I to n, this sort of suffix idea is slightly unmotivated, although basically the final form is we're looking for something like well, we want to represent f of ji. So the thing we're trying to do right now is we want to represent f of ji as something that only depends on I. Or actually, so here, this cost function is some function of f of j and I. And actually, let's make it inclusive. So it'll be the cost of traversing the segment j to I minus 1. Which means that position I will be after this, and so it's the cost to sort of get past this segment to this checkpoint. So it's inclusive of I, which means we have to go only to I minus 1. But the problem we have here is that this depends both on I and j. We want to separate these two. We want to separate all of the j terms from the I terms so that we can turn this into a line. And this is where math comes in. This is just like pure bashing out formulas. So here we go. How do we do this? One way we can do it is, like if we had some sort of prefix sum or something, we could try to represent it as, I'll put an equals question mark, something like f of I comma n, or something like f of j comma n minus f of I comma n, because this is the interval from j to n, and this is the interval from I to n, and if we exclude this part, then we get the interval from j to I minus 1, which is exactly what we want. You can also think of it like a prefix. In fact, that's probably easier to represent, so I may have overcomplicated a bit with this, but whatever you do, it just has to, you have to separate all the j's from the i's so that you can make a line out of the j's. Actually, you don't have to separate the j's from the i's. But what you do have to do is make it so you only have one thing that depends both on I and j, and it's this sort of line thing, where one of them is a constant that depends on I, the other is a constant that depends on j, and you're multiplying them together. Otherwise, it's impossible. to do convex Hull trick. But anyway, this is the idea. So this is our goal. Unfortunately, this is not the formula we can use. It's not that simple. But let's just like try this out. So in fact, we're going for f of jn. And again, this is the postulate of trying random things until something works. I didn't like think of convex Hull trick. It took me a while to just... I'm explicitly trying to force this problem to make convex Hull trick work. And to do that, I'm trying this random thing of using suffixes. There's no like you just gotta try things, man. When you have problems that are hard like this, you just gotta try things. So this is pj plus 1 plus ... plus pj ... pn minus 2. And actually, I'm solving for this to n minus 1 because that is, like, we don't include n because it's the end. So this is n minus 1, which is n minus 2, all divided by pj ... pn minus n minus 1. Okay, I'm gonna look at what I did here. Okay, now essentially, we know that j is less than or equal to, or j is less than I. So let's kind of split this sum up at some point I, which is sort of in the middle of this ... So let's sort of split this sum up for some value I. So therefore we get something like 1 plus pj. Like we're trying to, in this sum, find where f of ji plus 1 is, so that we can solve for it later. So to do that, we have to create f of ji plus 1, and f of ji plus 1, or I minus 1, sorry, is just the same formula, but it only goes up to I minus 1. So it's like 1 plus ... plus pj ... p I minus 2 all over pj ... p I minus 1. Can swing that over. Sort of like this thing under the green, this thing above the green blob is sort of like the ideals, the thing we're trying to like make happen. So this is 1 plus pj plus ... plus, let's make it go to this, to some arbitrary value pi minus 2, where it could be just any random I. And then we split that up here, and then we get pj p ... and there's also ... dots here everywhere, kind of pi minus 1. And then this goes on until m minus 2. It's like messy to write out. All of this over pj ... pm minus 1. So we now break this up into two parts, this part and this part, so that we get 1 plus pj. There's no good way to do this. pj plus ... plus pj pi minus 2 over pj ... pm minus 1. Also ... here, because this is an I, plus pj ... pi minus 1 plus ... plus pj, I hate these ... dots so much, pm minus 2, with the same denominator. Over pj ... pm minus 1. Now notice this is like very close to f of j to I. The only difference is that this goes to n minus 1 instead of I minus 1. But like we know that I is less than or equal to n. So what we can do is we can we can split this up. We can split this up into the part of, let's just use the collective numerator since I don't want to write it out again, over pj dot 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 pi minus 1, and then that times pi dot 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 pm minus 1. And then now this part that we have here is exactly f of j I minus 1. So this becomes f of j I minus 1 over whatever we have left in the denominator, pi dot 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 pm minus 1. Now also notice that if we didn't have a j here, then we would have like some suffix like f of I something to the m minus 1. Like it's a different suffix. And in fact, we can have some things cancel out because everything here contains this pj to pi minus 1, and so does this denominator. So let's divide everything by this value. And so we get 1 plus pi, because the next value here is pj to pi, plus pi plus 1, plus dot dot dot, we continue, plus pi dot 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 pm minus 1, all over pi dot 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 pn, which is exactly, where is this? Pause for dramatic effect, and I don't even find the function. Which is exactly f of I, comma, actually this should be m minus 1, this should be m minus 2, my bad. But this is exactly f of I, comma, m minus 1. So we get now f of j m minus 1 is equal to f of j I minus 1 over whatever this value is. Let's let it just be like some k or something, because I don't want to write it out every time. So over this value k plus f of I m minus 1. It's like very close to this thing here. It's very close. It's not perfect, but it's very close. So it's very close. So remember, our goal was to solve for this. So let's do some basic algebra here, as we've been doing. And so now we get f of j to m minus 1 minus f of I to m minus 1 is equal to f of j I minus 1 over k. And then f of j I minus 1 is equal to k times this, which I'm going to copy in again. F of j minus 1 minus f of I m minus 1. Which is, again, very close to the thing we were trying to get. It's just there's an extra k involved here. Yeah. Yeah, actually, it just is this thing, except it's multiplied by some k. And this k is simply some constant that only depends on I, pi, the product of pi to m minus pm minus 1. So if we break this up, so now we can represent k as some function h of I, which is to say, like, it's just the product of the suffix of I, the probabilities. But it's some function that only depends on I. So we'll represent it like this. And then we'll say h of I times f of j to the m minus 1 minus h of I times f of I n minus 1. So constant, constant. This is the only thing that depends on j. So for a given I, because again, we're trying to optimize this recurrence given that we know what I is and we're solving for the best j that does this. For a given I, all of these are constant. And in fact, this is the value of x. It's the value that's multiplied by the value that depends on j. So now we can copy this in. We can fix our recurrence to be this. dp of ci is equal to the minimum for j is less than, over j being less than I, of this. I'm not going to put the brackets. H of I times f of j comma n minus 1. This might be probably definitely easier to do this out on paper, but you know, whatever. Whatever, I'm stubborn. Minus h of I times f of I n minus 1 plus dp of c minus 1 j. So notice, this is a constant that depends on I, which means like we can just totally throw it out because this, we can take it out of this minimum because it doesn't depend on j at all. So we can kind of just like throw this out. Or we can't throw it out, but we can sort of ignore it, and we can add it after we find the minimum of this. This is a constant that depends on I. This is a constant that depends on j, and they're being multiplied together. And this is a constant that depends on j. So this is m, this is b, and this is x. We have a line. So provided we can efficiently compute h, which is just simply it's just a range product. And in fact, the way they give us the probabilities makes this very easy. So h is just a range product, but it's actually just dividing two of these f values. I'll leave that to you to figure out how to divide. So h is simple. This is like the values of f we can compute because it's just a formula that we can use prefix sums and products on. How to do that is described in this editorial, and I don't really want to explain it, so I'll leave it to that. Just like here, either Beautiful Mirrors itself or Beautiful Mirrors with Queries, the Div1 version. And then dp we computed beforehand. Like we're computing level C, which means we already have to have computed level C minus 1. And so for each level C, we build a convex Haltrick structure that represents the lines from the previous level of C. And then we go sort of like iteratively like this. For C equals 0, dp of 0I is simply just f of 0 to I, or to I minus 1. Because like there's nothing we can do here. We can't put down a checkpoint, so it's just like the whole thing. And then the answer is the minimum of C over dp of C comma n. Because we can use any number of checkpoints that we want. It doesn't have to be exactly k. But the point is like it's at least k, so we consider all numbers of checkpoints. And in fact, the optimal solution will use as many checkpoints as possible, but actually, there is an optimal solution that uses as many as possible. So you can print dpkn, and that works. But I'd like to be safe, so I did all of it. And yeah, I think that's it. I think that's all I wanted to mention. Convex Haltrick is a thing you can either copy in or understand. In fact, there's a cool YouTube channel that does this, so I will leave a resource to learn convex Haltrick as well, if you want. So the things I'm going to do are CHT video and Beautiful Mirrors. Those are the things that are going to be in my description. But yeah, so it comes down to computing this DP. Let's see. There wasn't anything else, right? Hiring workers, flip the string, chef. Yeah, that's pretty much it. Okay, let's see. Has my rating changed? Wow. This is so stupid. I am barely hanging on to the edge of red here. This is insane. Like, I've been 2502, which is barely red in the first place. 2543, not that much better. Then we dropped to 2522. Then we dropped to 2503, and now we gain 8. So 2511. It's insane how consistent I've been, though. Like, it's like a different level of consistency every time, but it's still consistent. And that's kind of crazy. But yeah, in terms of that, that's all I got. Hope you enjoy, hope you can learn something, etc. Alright, this has been going on long enough. I'll see ya.